Let's consider an Ethernet bridge. A bridge is going to separate a network into different collision domains. If a bridge has two ports, as early bridges did, that would give us two collision domains, as pictured here. We might have a hub connected into each of the bridge ports, and the hubs themselves, they're in their own collision domain, meaning that if a collision occurred because a laptop and a PC on one hub sent packets at the same time and they collided, that would impact everybody off of that bridge port, but it would not impact devices connected to the other bridge port. And unlike a MAU, unlike a hub, a bridge does intelligently make forwarding decisions. It's going to learn, as it sees frames flowing through the network, it's going to learn the MAC address, the media access control address, the 48-bit address that's burned into these network devices. It's going to know that the laptop with this 48-bit MAC address resides off of port number 1. And this file server with this other MAC address, it resides off of port number 2. Then, later on, after it populates this MAC address table, if it receives a frame that's destined for a specific destination MAC address, it's going to consult its MAC address table and realize, oh yeah, this MAC address, I learned it earlier. That's a MAC address that lives off of port number 1, and it's going to forward that frame out of port number 1. And a bridge is really the predecessor of the modern day Ethernet switch. Because, like a bridge, an Ethernet switch is going to separate our network into different collision domains. Each port on an Ethernet switch is in its own collision domain, just like a bridge. An Ethernet switch is going to make forwarding decisions based on MAC address information, like a bridge. One of the big differences, though, is performance. Back in the mid-80s and early 90s, when bridges were more popular, a bridge made its forwarding decisions in software, while an Ethernet switch has special circuitry called an ASIC, an application-specific integrated circuit that's going to allow the switch to make forwarding decisions in nearly real time. So it's significantly better performance-wise than a bridge. We also tend to have much higher port densities in an Ethernet switch as opposed to a traditional bridge. But getting back to the discussion of a bridge, this bridge has two ports, therefore this specific bridge has two collision domains. But what about broadcasts? Can a broadcast traverse a bridge? Yes, it can. In fact, we need a router. A router is going to separate broadcast domains. A bridge does not. That means that a broadcast sent from a PC off of one of our bridge ports, it's going to be seen by all of the other devices off of that same bridge port, in addition to all of the devices connected to the other bridge port. We're not blocking broadcasts with a bridge.